All right, so graphical user interface programming. And this is how you write modern software. I mean, when was the last time you ran a computer program and it made you type in numbers at a command line? It just doesn't work that way anymore. Everything everything now is done with mouse clicks. So first, I'm just going to review a few simple features that you can build in your programs with minimal effort. And then we'll go to talking about full-blown GUI programming using App Designer. So I've already shown you a couple of things. Back when we talked about cell arrays, I showed you how to do a dialog box. This is the same example. And then a message box. One more thing that might be useful is a file dialog. So when we talked about file input and output, we just typed in the whole file name. But you can also do it so that the user can browse for the file, the way you typically do in software. So there's a function UI get file, which will open up a file browser window like this. And if you want, you can restrict it to certain extensions. Like this says, show me all the XLS files. Now what this will do, so once the window opens up, the user browses around, selects the file he wants and clicks open. This will just return the name of the file. And then you open it just the way you would have. So if it's an Excel file, you could use XLS read, although that's kind of obsolete now. We're asking you to use read matrix now instead. You could use read matrix or read cell. Or if it's a general text file, you could use fopen. But the key thing is UI get file is just giving you the file name. So you store that in a variable, and then you use that variable name in place of where you would have entered the file name with XLS read, read matrix, read cell, or fopen. Okay. All right. One more thing is how to display an image. So we've done a little bit with this back in one of the exercises when we did this image smoothing problem. But here's how you do that. You do an IM read to read a file. So it could be a JPEG, a PNG, other graphical formats. And MATLAB will just store it in a matrix, or let's just say an array. And then you can display it by doing IM show. I just think it's a little interesting here to know how this is stored in MATLAB. So if it's a black and white image, as you saw in the exercise, it's just a matrix, 2D array of zeros and ones. Then you did some averaging to turn it into a grayscale image. And so that's a matrix of numbers between 0 and 1. A color image is actually a 3-dimensional array. It's got number of rows by number of columns, so number of pixels, times 3. Those are red, green, and blue. Okay, that's pretty much universally how computers store color images. They store 3 values for each pixel, a red, a green, and a blue. And with appropriate combinations of those 3, you can make essentially any color. Okay. All right, one more little concept that we need to be aware of before we get into GUI programming is the idea of a graphical object handle. So to apply this to something you're already familiar with, when you create a new figure or a set of axes or a plot, you can assign a handle to it, which is just a variable name that allows you to reference it later on. Okay, so I showed you earlier, a long time ago, to make a new figure, you just type figure. Or you can do some variable name equals figure, and that'll give you a handle that you can use to change the properties afterwards. So if you do figure 1 equals figure, it'll give you this handle that shows you the properties of that figure. Or this is a small subset of the properties. There's actually many more, but these are kind of the most important ones. Like the background color. And again, you see red, green, and blue. In this case, they're all equal, so you're just getting a general grayish. The position, where on the screen is it? and so forth. And similarly with a plot, you'll see the properties like the background color again, the line style, line width, is there a marker, marker size, and so forth. And with the axes, you can see the X and Y limits, whether it's a linear or logarithmic scale, and so forth. So not only can you interrogate, view the properties of a graphical object using these handles, you can also change them. All right, so let's say you've already opened this figure previously, and now you decide you want to change the background color. You can do figure1.color equals, and then whatever set of values you want, red, green, and blue. And remember this convention, these properties or fields will always be capitalized. Okay, or similarly, let's say you have this plot, and you decide you want to change the line style to be a dashed line. You do plot1.line style and put double dashes. Now the question is, why would you want to do that? Because you could have done this when you created the plot using a control string, right? Well, it's just, if you want to change it during the course of execution because of conditions. Like one example that I often give is, let's say you have a program that's making some real-time measurements, monitoring a process, and there's some range of values that parameter you're measuring is supposed to be between. And if it drifts outside of that range, you want to display a warning or something. Right? So if that value that you measured goes outside of that range, maybe you would make the line turn red as a warning or something like that. Okay. All right. But we're just introducing you to this concept because you're going to use this in GUI programming and App Designer. Okay, this is how you're going to change the properties of graphical objects, and you'll see why you need to do that.